Hello, Algebra 2. We're going to continue our discussion about logarithms and exponents today. We've talked a lot about exponential functions and a little bit about logarithmic functions. Now we're going to move into the algebraic portion. So just like we talked about with functions, a logarithmic function is the inverse of the exponential function. So we're going to talk about how that looks. How do you write a log as an exponent? How do you write it as the inverse? So let me give you a little hint here, and I want you to remember this. I'm going to write it in all capital letters. Makes it important, right? A log is an exponent. Okay, so when I say a log is an exponent, we're going to talk about properties today that we've learned before about exponents that we're going to start applying to logarithmic expressions, okay? And then next time we're going to talk about logarithmic equations. All right, so let's talk about this one thing. This is going to be super important. Writing a log has an exponent. And here's what it looks like, okay? Because when we talked about our functions, we said the way that you say it is log with base, right? This is your argument here is a, and this is your exponent. So you write this in exponential form this way, right? Base B, exponent C, argument A, okay? So writing a log as an exponent, this one, remember this one, okay? This is how we're going to solve all of our log equations, how we're going to evaluate logarithms, all of that jazz, all right? So big box around that. There are some other logarithmic properties and laws that are going to be very similar. Well, they're going to be equal. They're going to be exactly the same as your exponent laws. So let's do a little table here. We're going to talk about our exponential laws. And now we're going to see how they compare to our logarithmic laws. If you enjoyed doing the exponents, then you'll enjoy this. In multiplying, right, x to the a times x to the b, you add your exponents, x to the a plus b, right, when your base is the same. Remember, base is the same. It's the same thing with a logarithm. Log a times b is equal to log of a plus log of b, okay? Here's our next exponential law, the quotient law, right? X to the a power divided by x to the b power equals x to the a minus b, right? When you multiply, you add. When you divide, you subtract. Here's our logarithmic law. Log a divided by b equals log of a minus log of b. Last one here, our exponential law, or raising a power to a power law. If I have x to the a power raised to the b power, then you multiply, right? X, a times b. Same thing with logarithms. It's going to look a little bit different though. Log of a raised to the b power is b times log of a. So just notice that difference there. Remember I said it's an exponent, right? So you're treating it like an exponent. Notice in my logarithmic laws that you don't have bases here. So I'm going to tell you something that you'll need to know, especially when you're using the calculator. Most calculators understand logs with a base of 10. So we'll learn pretty soon how to change the base. If I have a base that's not 10, what do I do? We'll learn that in our next section. But just know that when you're evaluating and you're plugging into a calculator, your calculator is only going to understand a base of 10. In your Desmos, you can plug in a different base. If you're in your Desmos Scientific, it only understands a base of 10. So we'll learn pretty soon how to change that base. Let's do some examples of rewriting logs. Here's example 1. So if I have 81 to the 1/2 power, we're going to follow our little box up here of rewriting logs as exponents. If I have 81, this is A, 81 to the 1/2 power equals 9, I'm going to rewrite it as log base 81 of 9 equals 1/2. Okay, that's our rewritten form. Here's B. 7 to the 2nd power equals 49. Here's our rewritten form. Log base 7 of 49 equals 2. Here's our last one. 16 raised to the 2nd power equals 256. Rewritten as log base 16 of 256 equals 2. Okay. Let's move on. We'll go the other direction. Here's our example 2. A, log base 11 of 121 equals 2. Rewritten as an exponent, remember your base is there, it's the same. 11 to the 2nd power equals 121. And you can kind of verify that these are true, right? Because 11 squared is 121. Next one, log base 216 of 6 equals 1/3. Rewritten as an exponent, 216 to the 1/3 power equals 6. Last one, C, I'm running out of room. Log base 9 of 81 equals 2. Rewritten as an exponent, 9 squared equals 81. All right, so that's just taking your exponential form and rewriting it as logarithmic form. Now let's look at these exponential laws. What we're going to do is, this is called expanded form, and here we have it condensed form. So we're going to look at how we can translate from one to the other. There's the now you try. We'll talk about that in class when we get back together. So let's go ahead and go to example 3, and we'll practice condensing these logarithms and writing them as a single log. So here's example 3. We're going to go through these together. Here's A. We have log base 4 of 2 plus log base 4 of 32. Biggest hint here is that our bases have to be the same, right? So I'm going to put this note here. Bases have to be equal, right? In this case, they are. They're both 4. So I can go ahead and condense the logarithm to be log base 4 of 2 times 32. And 2 times 32 is 64. So log base 4 of 64. So these are just expressions. The last ones, they were equations, so we could confirm that they were equal. In this case, we're just rewriting the expression, kind of like combining like terms. So we're not finding a solution. We're just rewriting it as one log. All right, here's B. Log base 2 of 32 minus log base 2 of 4. So when I subtract, I divide. So rewritten is log base 2 of 32 divided by 4. In other words, log base 2 of 8. Okay, moving on to C. log base 3 of 81 raised to the second power. Power to a power you multiply. So I'm going to bring that 2 into the front. 2 times log base 3 of 81. Remember, it's an exponent. So we're multiplying it by that exponent. All right, let's look at D. Log 3 minus log 8. Notice we don't have a base here. When there's no base, it's an understood base of 10, just like we saw earlier. This is how your calculator would read it as well. It won't allow you to put that little base in there. You have to do the change of base, which we'll learn later. All right, so when I subtract, I divide log base 10 of 3 divided by 8. Can't simplify that anymore, so I'm going to leave it as is. Okay, let's look at E. What does this say? My printout was not very helpful, so let's see what my notes say. Oh, it doesn't say anything. Let's say it's 2 log. I'm not sure. Don't do that one. I'm not sure what it says or what it's supposed to say. Let's do F. Log, it must not have been that important. Log base 7 minus 2 log 12. All right, so this is interesting because we have an exponent here, right? So if I have an exponent, but I don't have an exponent here, I really can't do anything. So what I'm going to do in order to put those together is I'm going to go a little bit backwards here. So log 12 to the second power. I know that that's 144. So we can do log 7 minus log 144. Now I can combine those to be 1. So log base 10 in this case, 7 divided by 144. Now I've written it as 1 log. I wouldn't be able to put these together because this is not 2 times log 7. So if I put them together, I would need to know that it only goes with this one. That's why we moved this to exponential form there. All right, so those are our examples for 1, writing a logarithm as an exponent. Remember, a log is an exponent. We're just rewriting it here, using it differently. And then we learned how to condense logarithmic expressions. Now it's your turn to try. Apparently the letter E's, I'm not sure. Don't do this one because I don't know what that says. So don't worry about it. And I'll see you soon.